Hi, we're Team 4. My name is Pablo Wada.
My name is Jeff Charles.
My name is Manuel Duran.
Hi, and I'm Yusuf.
Awesome.
Our first part is set up like this. It's pretty, we're using the LED light, same way as our lab one. The only difference in this lab is like we're adding the temperature sensor and a buzzer. So as our first lab, the LED light, the longest leg is connected to the resistor, and then this resistor is going to the digital pin D2. Then the shorter leg is connected to the ground, like by using this orange wire. For the temperature sensor, this has like 3 legs. The left side of this sensor is connected to the ground. Let me push this down. And then the middle one is connected to the analog pin A0. Then the right side of this sensor is connected to the 1K ohms, which is followed by this red wire, which is in 5 volts. Then for the buzzer, this has 2 sides, one negative and one positive. So the negative is going to the ground, and then the positive is connected to this resistor that is followed for this orange wire, which is connected to the digital pin number 9.
So in part 1 of this lab, we're doing 2 things. We're collecting the data from the temperature sensor and graphing it against time. And we're also comparing the temperature of the temperature sensor to a threshold value that we choose. And whenever it reaches that threshold value, we're telling MATLAB to send the signal to the Arduino to light up the LED and to also make the buzzer go off. So what we do here is that we start the timer, of course. We set our variables for the voltage. This is going to store the voltage of the temperature sensor, and this is going to store the time that has elapsed. This, we set up our threshold for 31.5. This is in degrees Celsius. Later on, we convert the data from the temperature sensor because it originally comes in 10 millivolts over Kelvin. And we, over here, we take the voltage divided by 0.01 and subtract 127 to convert it from Kelvin to Celsius, just so that we have something that we're more familiar with for the data collection. So right here, we have the graph that it's already set up. We have our X label as the time in seconds, our Y label as the temperature. So what we do is that we set up this while loop that runs for 30 seconds. What it does is that it collects the voltage from the pin A0, which is our temperature sensor, and then of course it converts it to Celsius, as I explained before. Then it takes this data, it stores the temperature in Celsius that we converted in our VV variable, and then it stores the time that has elapsed in the time variable. And then it takes these and it plots time against the temperature. Wait, one second. We also have our condition in this if loop right here. So if the temperature from the temperature sensor surpasses our threshold value of 31.5 degrees Celsius, what it does is that it sends a signal to digital pin D9, which plays the tone on the buzzer, and it also sends a signal to digital pin 2, which turns on the LED light. And now we're going to run it. So right now it's just collecting the data from the temperature sensor. Pablo's putting his hand on the temperature sensor right now to see if it could get it to reach the threshold value. It is a little cold in the room, so it is a little harder for it to reach it. Oh, you don't have it running for 30 seconds. Yeah. Okay, so again, it's collecting the data from the temperature sensor, graphing it against time. And then now we're trying to get the temperature sensor to reach the threshold value by putting our finger on it. It's getting there close, but it's not all the way. Oh, there it is. So around right here, it's surpassed our threshold value, and oh, around right here, it's surpassed it again, and you hear the sound from the buzzer. And then it just went on to collect it for 30 seconds. And then here's the graph afterwards. All right.
And then for part 2, well, party actually. So we first are telling MATLAB to get, to every time the time and the voltage variables goes up or goes above 1, it starts to collect that data. So basically what we're doing is taking these values, like the time and the voltage variables, or the times we're collecting there, and we are plotting it into, or we're using it for the differential function. Basically what it's saying is that every time these values goes above one, it's gonna take the difference between those consecutive points, and then it's gonna use it and then store it in these variables right here, in the time difference value and the temperature difference value. So then we calculate the rate of temperature change, which is just a formula. Basically to get it is the temperature difference divided by the temperature, the time difference, sorry, and then after getting the temperature rate, we're getting the average of it by using the absolute value function and then the mean value, or the mean function to get the average rate, of course. And then to plot it, we are just getting this rate time because that way we can plot it on the plot, on the graph, and we can get the rate of temperature change versus time. And after we display the result, we're telling MATLAB to get those answers or the results, and once it gets the average rate, or once the average rate goes above one, it's gonna take that data, it's gonna plot it right here, which is gonna take the estimated time, which is basically the absolute value of the threshold minus the first value of the voltage that we're getting, which is just basically saying that we just wanna take the first value and divide it by the average rate. This is just a formula. It's important to add the absolute value because the first time we were getting a negative value, we were getting like something really crazy, like infinite, and doesn't really make sense. But once we add an absolute value, we get a positive result, and we get like a result that makes more sense, as you will soon see. Then after that, we're getting the actual time, which is basically the actual data that we're getting. So it's just a simple loop, and yeah, after we get this data, it's gonna display it. It's gonna display this estimated time as well, and then it's gonna take these two values and it's gonna detect the error percentage of it by just using the regular error percentage value, and then it's gonna display it, as you can see right over here. So now my friend is gonna display the graph, and as you can see right over here, we have the real temperature change versus time. And after getting those results, we're gonna get this thing right over here, which is actually a pretty good result. Look at that. The estimated time is 14 seconds and the actual time is 18.5 seconds. And then by getting the error, we get 31.5%, which makes sense. So thank you so much.
And now we have our code that we did for lab 2. So the overall assembly of the code was a little bit more difficult than anticipated. We were having difficulty setting up the voltage to actually display the correct voltage onto the charts. We were having issues trying to convert it into Kelvin. To convert it from Kelvin to Celsius, which was an overall great issue. But the assembly for the circuit was pretty simple compared to last week's project because it was kind of based off of that one overall. And this is the second segment of our code, which was honestly pretty straightforward to assemble that one. And we would repeat the experiment a few times, and we would try to decrease the overall error value so we could be above a 95% confidence interval. And in our final run, we got a estimated time of 20.13 seconds, and we received an actual time of 19.21 seconds. And so the actual error was only 4.53, which is below 5%, which is where the area we wanted to be overall. And thank you for watching.